Okay, it's going to run through some problems for 4.3. Here's number 11. It says secant theta equal 4. Okay, well, let's think about what the secant is. The secant is the reciprocal function of cosine. Cosine is adjacent over hypotenuse. For secant, I flip the fraction. That would tell me that's hypotenuse over adjacent. So, if I got 4 for the hypotenuse, and I put, let me just make a fraction of it because I need a fraction. I can put 4 over 1. What I'm going to do, if you read the instructions, is sketch a triangle, find the third side, and find the other trig functions. This was like number 15 that we did in class. So I'm not going to work 13 just because we had one example from class, and then we'll have this one on video. Okay. If the hypotenuse, here, let's put our angle here. I'll just put whatever my angle is here, and they're asking me not to find the angle, but to find all the trig functions. So what they're wanting me to do, let's kind of just think about what they're wanting here. They're wanting sine, and they want the reciprocal of sine cosecant. They want cosine, which we're going to be able to find pretty easily because we already know the reciprocal of cosine is secant. And secant is 4, or 4 over 1, as I wrote up there. So if I flip that fraction, the cosine will be a 4. So I've already got my cosine. They also want tangent, and they want cotangent. Okay. So what we did on number 15, if you remember in class, was that we said, okay, if the hypotenuse is 4, let me label it. And then the adjacent side to my missing angle, which would be down here on the bottom, would be 1. So, and again, I had to make that fraction 4 turn into 4 over 1, but that I can say my hypotenuse is 4, my adjacent is 1, and now I can use the Pythagorean theorem to find the third side. Use Pythagorean theorem to find third side. Okay. So whichever function they give you, you just kind of got to say, is it, go to SOHCAHTOA, and if it's a reciprocal function, you're just going to take, like in this case, this was a reciprocal of cosine. So I knew cosine was adjacent over hypotenuse, so for the reciprocal function, I just flipped it. So that's what you'll also do on number 13. It's very similar to this. You'll just have the opposite over adjacent for number 13. Okay, anyway, get into this one. Let's do the math on that. I'm missing a leg, so 1 squared plus the missing leg squared, I'll just call it x squared, is equal to 4 squared. So my missing side is basically, this is going to be 16 over here, and when I subtract 1 from both sides, I get x squared is 15. So this missing side, if I got a square root, the missing side is the square root of 15. So let me fill that in on my triangle. Now I can do all my trig functions really quickly. The sine of this angle is the opposite, which is square root of 15, over the hypotenuse, just looking down here at SOHCAHTOA, which is 4. If I flip that to get the cosecant, it would be 4 over square root of 15, but I got to rationalize the denominator. So I hope I can squeeze this in. This is 4 square roots of 15 over 15. Now, all the one we got left is the tangent. Tangent is opposite, which is square root of 15, over adjacent, which is 1. So the tangent is just the square root of 15. The cotangent would just be flip that, so it's 1 over square root of 15. But I need to rationalize that denominator. So it'll be square root of 15 over square root of 15, then I multiply by, and I'll get square root of 15 over 15 for that answer. So here are my trig function values. Let me circle them. This was the other one right here. And they gave me 1. So just from one fraction, I could go figure out the whole triangle by using the Pythagorean theorem, and then I could come back and just use SOHCAHTOA and the idea of flipping fractions for reciprocal functions to figure out these. So 13 would be like that. Okay, so on number 45, it says use the given values and the trig identities to find the identified trigonometric functions. Okay, so here's what they want. Let me just kind of come and make a little workspace over here where we can write our answers. They want to know what the cosecant of 30, no, I'm getting off on the wrong problem. They want the sine of the angle. They want the cosine of the angle, whatever it is. They never really asked me what the angle is, if you notice. They want the tangent of the angle. And then for D, they want the secant of 90 minus theta. Basically, they want the secant of the complement of whatever our angle is, and probably on that part, we're going to need to flip over to page 279, and if you look there, there's a, at the very bottom of the page, below the blue box, it says the secant of 90 minus theta is equal to the cosecant of theta. So once I have the cosecant of theta, I do, don't I? That was in the given information. I can actually do D just by using that little trig identity. The answer to D is just 3, because the cosecant was our given information up here, and the secant of 90 minus the angle is the same thing as the cosecant of the angle. They're basically saying if you draw right triangles and you make all your fractions, your some of your sine and cosine, for example, of some of your angles, the sine of one is going to be the cosine of the other, and the cosine of one angle will be the sine of the other. That's really what those identities are telling me. I can just use them without understanding that, but it's kind of nice if you remember it, because it'll make recalling some values a little easier as you work. Let's go ahead and let's look at this. What do we know about cosecant theta is 3? Let's go ahead and write SOHCAHTOA, because they never asked me for the angle, did they? They just said, find these trig values. So I don't really need to know the angle. And because they didn't ask me the angle, it's a very good possibility it's not one that would be helpful with the 30, 60, 90, or a 45, 45, 90. So let's think about this. The cosecant is a reciprocal function of sine. So sine is opposite over hypotenuse. My cosecant would be hypotenuse over opposite. And they tell me it's 3. I need a fraction, so I'm going to fill in with a 1 there. So here's what I can do. If you remember, this is just like problems 11, 13, 15 earlier in the assignment. They just sometimes can make them look a little bit different. The hypotenuse is 3. Let's put my angle here. The opposite side from that angle is going to be 1, because that's what what we see here. So we're using that. We're going to fill out our triangle using the Pythagorean theorem. And if you remember, the hypotenuse squared, which would be 3 squared, would be if I take the hypotenuse and I subtract one of the legs squared, which I only know that one, I'll get the other leg squared. Let's just call it A for adjacent side or something. So 9 minus 1 is A squared. If I square root both sides, I get A is the square root of 8. And that is, square root of 8 is the same thing. I'll go ahead and do the simplifying here. Same as I could replace 8 with 4 square roots of 2. The square root of 4 is 2, so I bring that out of the radical. And I get, this adjacent side right here is this 2 square roots of 2. And that's not one of my answers, but I'm going to use it for my answers. And here's how. Again, this is just going like back up to number 13, 15, 11, all those. Sine is the opposite over the hypotenuse. It's also, you know what, sine and cosecant were reciprocal, so I could have just said if the cosecant is 3 over 1, I'm going to flip the fraction and get 1/3. Let me just do it that way. If you go look at the triangle, the opposite side is 1, the hypotenuse is 3. You could get it either way, okay? It's easier to flip the fraction, I think. The cosine is your adjacent value. Oh, well, that's just going to have to stay. If I do something to it, the video won't load. That's just a thing with this app. All right, the cosine is the adjacent over hypotenuse. And the adjacent side, if you look, that was what we found right here using the Pythagorean theorem. That's going to be 2 square roots of 2 over the hypotenuse of 3, okay? The only one I've got left to do is C, because remember, we did D first just because I was discussing where you would go look to find the information to do that, and then we noticed that one was an easy one to work out. Let's come over here to do C. I kind of don't want to squish it in there. Let me use green just so it'll kind of stick out. So we're going to come over to the side and use green. My tangent of my theta, if I just want to use the triangle, there's a couple ways I could get this. I know that the sine over the cosine would give me the tangent, so I could make a fraction over there. I could go to my triangle. That's what I'm going to do just because, that's just as easy or maybe easier. Tangent is opposite over adjacent. So the opposite side is 1 in that little triangle, and the adjacent side is that 2 square roots of 2. All right, but we don't want to leave it like that. We need to rationalize the denominator. We don't want fractions in there, so I need to multiply by square root of 2 over square root of 2. And I end up with square root of 2 over 2. Now, the square root of 2 times the square root of 2 would just give me another 2. You could think of it as Square root of 2 times 2 is the square root of 4. Square root of 4 is 2. However you think about that, you're going to get another 2 on the bottom. That ends up being square root of 2 over 4. That's my tangent value over here, and I'll write it over here just so we have it with the answers here.